we're now rejoined by Freeman Jack. Jack, thanks very much for coming back.
Good evening, Nick. I'm so sorry to the listeners for having to delay you for so long. Just had a bit of an urgent matter to attend to here.
Yeah, indeed. Yeah, sometimes reality does impinge on the radio a little bit, doesn't it?
It does at that.
Honestly, having finally grokked the kind of stuff we were talking about last time, and I was saying whilst we were waiting for you to arrive, that it's taken me 3 or 4 listenings really to get it in, even having followed your kind of chat boxes and links as you've gone along. But it really is, I think, tremendously elegant, the whole thing, the idea that everything
and as I said to you earlier, same here. Because this doesn't feel like it's coming from me. It feels like it's coming through me. And on rewatching the video, I'm hearing my own voice and seeing the images on the screen, and it's having much the same impact on me as it appears to be having on everybody else.
One of the things that thinking about your stuff has really brought up for me big time over the last week is how far there appears to be something wrong with our sort of normal science, our orthodox science, because you've been saying all the time that there's bits of it missing, and when we look at what the work you're doing with the tools you've got, we see that really quite exceptional and amazing results are being got by one man with a very small budget, and science doesn't, to a certain extent, appear to be getting us anywhere. Where do you think the biggest problem lies? Why do you think the big machine
the biggest problem lies basically in the university system in and of itself, because of the unifying effect of university is to bring a lot of minds into focus about a single point, about a single subject with a single doctrine. And those subjects are taught more or less in exclusion of any other subject. And I don't see how it's possible to understand biology without knowing chemistry, or chemistry without knowing physics, or physics without knowing higher math. So unless you're a polymath, a natural polymath, and have an innate understanding of all of those subjects anyway, then your field of speciality is going to do nothing but limit how you can possibly think about a subject, not expand it.
Which I suppose is one of the big advantages you have over the university educated, is that you've had polymathematic experience.
Yeah, broadly, yeah. I don't think I ever intended to set about to achieve any sort of polymath status, but I appear to have arrived at its doorstep, whether I like it or not.
It's funny, really, that we've highlighted on the university thing as the first concern, because I noticed when I was there, I was only doing English, which doesn't count for much, but the whole thing would have been a lot better if I was being taught a bit of music and a bit of history and a bit of science to give me some sort of context for the other stuff that I was reading. And it was my biggest complaint, really. But I've got a lot more complaints about it now.
To be quite honest, what actually happened in the first place was that there would have been the 4 doors of the quadrivium of the 4 classic arts, as they were known. And a normal university structure would have had 4 buildings facing a quadrant, and each of those doors would have been an entry to that particular department, and people would liberally move between departments. So you would walk out of the music door and into the astronomy door, and out of the astronomy door and into the maths door, and one might go and visit lecture halls in all the subjects. And I think that what happened is, as the university concept expanded, those buildings crept further and further apart until now they're on different continents. And the people don't talk to each other or understand each other's language. Again, semantics. A biologist can't understand a physicist.
And as a result, very little progress is being made, because they're not actually several subjects. Again, as your research is showing, your research is pointing to a holographic unity rather than to a sort of separation and analysis of everything. So, what about our basic models of science? I mean, Newtonian science has been well established for a long, long time.
Well, Newton, I mean, as much as I dismiss Newtonian mechanics as being bunk, that's not in any way a denigration of the man Newton himself, who was an absolute towering genius. Funnily enough, actually not quite as towering as everybody thinks, though. he actually told us exactly what he did. He said, "I have seen further than other men because I have stood on the shoulders of giants."
Yeah.
And that's essentially what he'd done, is he'd gone and looked at every single philosophical treatise, every single doctrine in science. He was the legitimate polymath. And we have calculus. We have him to thank for calculus, and calculus is the maths of the modern era. Modern era would be impossible without calculus, and it took a genius like Newton to come up with calculus, and calculus is essentially the maths which orbital mechanics rely on. So we wouldn't be able to predict the orbits of the planets as accurately and send spacecraft out there and things like that if we didn't have calculus.
Right, and is the rest of his science still nestling nicely and surely in amongst everything else, or do we have any trouble with any of it? Quite apart from the fact that a lot of stuff he did wasn't published.
I've recently found, since discovering that I'm now relatively satisfied that gravity isn't a force, it's an effect. I began to sort of be very dismissive towards Newtonian gravity because of that, only to find out that Newton, I don't think, ever actually described his gravitational theory as a force. He was absolutely unsure where the actual effect came from, but certainly wasn't, in any way describing a force. And even Newtonian mechanics, the laws of motion, again, aren't his. It's actually, if anybody wants to hear the Newtonian laws of motion proved not to have come from the mouth of Newton, go to Thomas Hobbes. The audio book of Thomas Hobbes' Leviathan, and jump to, I think it's about 13 minutes in, and it's the start of the second chapter. And in the very first paragraph of the second chapter, you'll hear in Hobbes' own words all of the Newton's mechanics basically being described as applying to human beings and their actions. So although Hobbes hadn't quite made the extraction that this was how the physical world worked, Hobbes was using the known laws of motion, which now we get as Newton's laws of motion, in 1753, I think. He wrote Leviathan, and Newton would have been precisely 6 years old at the time.
Right. So that's another thing, isn't it? People
that particular chapter with it is often said in many of the great universities that, and then goes on to present the three laws of motion.
Right. Yeah.
So even Hobbes is basically saying this isn't my idea. This is said everywhere.
This is another thing, isn't it? A lot of ideas do seem to arise and then stay in the background for an unconscionable long time.
I think another problem with science today is that we've been given this cult of personality. I think this goes almost to the Romanian cult of Mithras, that we're being presented with the cult of personality rather than the philosophy of their ideas.
Yes.
The likes of Einstein and Bohr and Faraday and Newton and Darwin all get lauded as these great and good men that, had these incredible ideas that are completely unquestionable because they were so great.
Yeah.
That's dogma. That's not science. We are here to question those great men, especially if they lived that long ago and didn't have access to the information that we've got now. It would be foolish not to.
We know ourselves, don't we, from just revisiting books and things, how a couple of years learning can completely transform work that you thought you'd already done.
Well, every time I come on the radio, I come off the radio and within 1 or 2 days, I'll find some piece of evidence that would have been absolutely key for me to have known at the time, but that I had absolutely no awareness of when I actually went to air. It does it every single time.
It makes the broadcasting itself actually something of a creative activity, doesn't it?
Absolutely. Absolutely, and moreover, that's the very thing. That's the trinity of mind that happens every time we discuss something with somebody else. That my trying to express my ideas in such frame them in such a way that they will meet your ears in an intelligible manner that I know that you will be able to understand, and then from your responses and from your questions, that understanding of your understanding will become refined, and through the process of the dialogue, through the grammar, the logic, and the rhetoric being constantly repeated through themselves, that as you say something with your mouth, you're acting on it with your mind and decoding that through grammar. Why the specificity of language is important in the grammar is because in order for you to be able to understand my words and for me to be able to understand what you're understanding of my words, we have to have that specificity of semantics in order for the rhetoric to work. And we know we get that bullshit filter cut in, and that alarm bell rings in the back of our head if the rhetoric is wrong. So if I'm telling you something and I'm saying the words, but I know that there's something wrong here, my logic's already working on the words as they're coming out of my mouth and correcting them. So with the Christian scientists, you have this sort of fundamentalist idea of the corridor monitor God watching over your shoulder at all times. And I believe, honestly, that a lot of scientists, right up until the modern day, end up in places that they fear to tread.
It certainly was true of
that
most of the
like
fathers
of on God's toes. Like Einstein said, I don't believe that God plays dice with the stars.
But it brought all of the fathers of quantum science to that kind of edge of realization, didn't it? Just the science they were doing.
Mm.
So
even the Big Bang Theory is essentially just a creation myth overlaid with an overcoat of mathematics.
Which is
the nearest thing that you've got to substance to the Big Bang myth is redshift. And redshift can easily be explained a dozen different ways. It certainly doesn't have to be because of everything's retreating from us.
But they were looking for evidence to support what they currently believed. So you don't think that like Bohr and Einstein and
that still thinks that redshift describes the cosmos as we perceive it needs to go and check out Halton Arp. He was one of Hubble's colleagues. He's recently died. Halton Arp's work on... Somebody happy to see somebody. Halton Arp's work on redshift essentially pointed out that all of the redshift values were in clumped bands. Again, very much like our electron rings and our ball capacitance spheres of separation.
Yeah.
All of the redshift values appear to be clustered around very tight little bunches of values, so they go up in steps. So redshift isn't linear. Everything isn't expanding away from us equally. There appear to be steps in if this is expansion. And moreover, Halton Arp spent most of his career researching single objects, or at least connected cosmic objects that shared very different redshifts. So essentially you'd have a central large galaxy cluster with a particular redshift and a sort of a north and a south ejection from that cluster, and the north ejection would have a massive redshift and the southern one would have almost none at all. And these are all coming from basically the same place in space. So it just simply decries the whole concept of redshift being somehow an indication of movement, of motion.
Which smacks, I mean, this is what I mean. It kind of smacks of total failure, doesn't it? In terms of the science. If when you've got all the clobber to observe something, you observe it, decide what it is, and then don't bother to think about it again. We're not getting very far.
I'm going to this week's Omniversity is holographic reality theory, and I'm honestly going to suggest that the creation of the giant telescopes may not be studying objects that are in distant space, but may actually be putting those objects there through their observation in exactly the same way that the double slit experiment collapses the delta T around the probabilistic nature of the electron being a wave or a particle according to the observer.
I'm so pleased to hear somebody of your knowledge and wisdom saying that, because I've had a kind of magical suspicion myself that there's a bit of that going on.
Literally, I remember as a child being an avid watcher of the sky at night, and being very keenly aware of how broad a catchment the majority of science was based on. So a scientific discovery would be considered to be a scientific discovery if it fell within some quite broad footprint of possibilities and that there'd still be quite a lot of fudge room and not shores, and well, it's that 60% of what we modelled, but not quite what we expected. And there was this sequence of huge telescopes being built. I think the Arecibo may have been one of the first ones that I remember. I think that would have been earlier. No, that would have been the 50s. Anyway, it was some of the big radio telescopes that started going up in about 71 that I started paying attention to. And by the time we were in the sort of mid-70s to 76, I'm very keen on astronomy. We'll watch every single sky at night. I'd stay up to watch it at night as well as watching the repeat that came on in the afternoons. And I remember this sequence of telescopes being built. And each one was, we've discovered this fabulous new thing out there with this optical telescope or whatever it was. We can't quite resolve it. It's just we're at the limits of observability. So we're going to design this big, fabulous new telescope so we can resolve this distant image. And then he'd come back on sort of 2 years later and go, the results are in from the new whatever it was telescope, and they're absolutely fantastic. They're within 98% of the predicted. And this was repeated time and time again. It was like they were seeing these things that were like fuzzy little blobs off in the middle of nowhere that nobody would really pay any great attention to, spending millions and millions of pounds going to huge lengths. I mean, putting telescopes on the tops of mountains, sending them up into space, inventing entire new engineering sciences in order to construct bigger and bigger mirrors or bigger and bigger receivers. And each time the results came back within this really narrow margin of error, and science doesn't work that bloody certain. And I began to get an inkling then, right back then when I was about 12, well, is it really that object has now been resolved? Or are these telescopes somehow projectors, not receivers? And
what a great idea.
Got to the point now where I suspect that this place may be the seat of consciousness, and that we're literally projecting the universe out there. So aren't going to be any aliens coming from outer space, because we're it, guys. Because we're putting all that out. The only way that aliens are going to come from outer space is if we imagine them there in the first place.
See, the twin slit experiment and various really amazing variations that have been done on it since did kind of indicate to the physicists of the time that there was an element of this in their reality, but it doesn't seem to me that they're taking that into account in any of the work that's done afterwards.
It essentially created what's known in science as the hard problem. It created in science what's known as the hard problem, and created the duality, non-duality division, where essentially you have the dualist. The dualist scientists have basically separated consciousness from everything else. So they study everything else and they leave consciousness well alone. And in fact, they actually exclude it anywhere that it arrives, or do their very best to exclude it whenever it arrives. And then you've got another whole bunch of kind of sort of Eastern philosophy-minded scientists that aren't satisfied with that and have now started a school of thought known as the non-dualists. And they're busy trying to unify physics and consciousness, mainly through sort of Buddhism and those sort of Eastern mysticisms.
Well, they do appear to. Well, it's a bit like you said. They're trying at the moment to explain gravity using gravity. It's a bit difficult to examine consciousness using consciousness for the same reason, but much more complex. We've got a question from Jimmy in the chat. Go for it, and then I'll come up with Jimmy's question.
No, go on.
Jimmy says the question that Jimmy asked was one that flew through my mind when I was listening to your explanation of gravity earlier. He says, if the planet stopped, would we all fly off it?
No.
That was the conclusion.
No, because it's got nothing at all to do with the rotation of the body. It's to do with the polarity of the body, and the Earth wouldn't change polarity whether it rotated or not.
So it's just layers.
It's the same reason why you'd stand on the moon.
Yeah.
Again, perhaps I didn't do enough of a decent job on New Year's Eve, but essentially what we're talking about here again is this electron dipole effect, which is essentially where the massive nucleus can be considered as being fixed in space because of its mass and because of its electrical neutrality of a sort. and the electron is free to move in its orbit, a bit like a planet around a star. And so effectively in an electrical field, the electron will be diverted from its normal circular path around its nucleus and will be pushed or pulled, either pulled by a dissimilar charge or pushed by a like charge. So in a negative field, the electrons would all move away from the source of the negativity, and in a positive field, the electrons would all be attracted towards it. And because of the way that electricity works at a distance, so that in the same way that when you bring two magnets together, they don't have to touch for you to be able to feel the effect. And the same way that an electromagnet, when you power it up, will grab a nail from the bench sort of 6 inches below it, or pick up the big ones in the scrapyards will pick up the car from 3 feet before they actually touch. Mm-hmm. And so we can actually see. In normal reality, that electricity and magnetism, which are essentially two versions of the same thing, have this spooky action at a distance, as Einstein liked to call it. And because of this, that all of the electrons in your body will be distorted by the same amount by the Earth's positive surface. So essentially, because the Earth's surface is positive and all the atoms in your body have these negative electrons, they're all attracted to that positivity and fly an eccentric path around their little central sun, their nucleus, towards the positivity. And this basically attracts us towards the Earth, because all the atoms in our body have this dipole where the negatives are all being attracted by the positives. And conversely, the tops of the atoms have all become slightly positively charged and are being sort of pushed down by the sky as well.
So it's a tremendously weak charge that's made up of layer upon layer upon layer upon layer of even weaker charges, but all working together.
Well, essentially, if you think of the diversion of the electron being created by the positivity under your feet, then gravity would be much, much stronger. But because we stand on a ball, and because it's an incredibly big ball, gravity is much, much weaker, because the electron is being diverted not only by the positivity under your feet, but going off in all directions that the Earth is. So everywhere that's down, but down is also kind of sideways, you know what I mean? We can see for 20 miles before the curvature of the Earth kind of rolls over the horizon. So, you know what I mean? Our personal gravitational field is right to the edge of that radius. So we're kind of sitting in a sort of 40-mile circle of electrical attractivity of a slowly weaker and weaker nature the nearer you get to that sort of edge of the radius. And we're also attracted to all of the other atoms in the planet by the same or opposite forces. God, so there's a whole push-pull thing going on, basically.
It's an amazing vision of.
And a lot of the charges either equalise and become neutral because of it, or they're simply again this exponential curve, this inverse square law, where forces become 4 times weaker at 1 times extra distance, but work over a 4 times greater area.
It's a fabulous vision of a kind of unified and balanced dance between everything and everything else. It's a shame we can't make the finances work that way.
Well, you say that, but I think it really does. If I'm right about this, everything works the same way. And in a deeper understanding of how everything works, we even begin to understand how we work and how our patterns of behaviour and our biologies and everything all interplay. It occurred to me that the lion and the zebra herd are in a semi-symbiotic relationship, although obviously the zebra herd don't predate on the lion or create the lion any particular risk apart from sort of kicking when they're in the hunt. Broadly speaking, the lions predate on the herd, but the herd benefits from that predation because the lions basically remove all of the weak and the infirm and the unsuitable for the herd from the herd. So the predation of the lion actually improves the genetic structure of the herd and actually makes it more likely for the herd members to survive if there's difficulty. And it suddenly occurred to me, well, what's the laziest bloody lion on the plain? It's the one with a gut full of zebra. What's the fastest lion on the plain? The one that hasn't eaten for a week. Food is a regulator. Food is a regulator of predation. And predation is a regulator of genetics. So again, we had this perfect sort of meeting of two triangles and almost an inserting it. We have this like star tetrahedron of forces, and somehow there's a harmonic inside that structure. So you've got the point of predation and the tail of weak and unfit stock meeting at the point of predation. But that predation isn't able to progress any further into the larger structure. But it's predating on because of this regulation of food, you know what I mean? If the lion can only eat so many zebra, and it appears to only be able to hunt effectively when it's hungry.
So although it looks like nature red in tooth and claw, it is actually another action of balance in the whole system. Yeah, and effectively, I think that it bodes humanity well to understand the way that nature pushes back if anything pushes too far in any given direction. It's certainly the way a good gardening regime works is to study the activities of the things that are going around you and trying to bring them into balance rather than just kind of like attacking them willy-nilly. Understanding them and using that knowledge works better than just trying to hitting the garden with a set of slug scissors or something.
Yeah. So you don't have a slug. You don't have an excess of slugs. You have a duck deficit.
Yes. Yeah. So you don't think that the acquisition of science by Bohr and Einstein and Pauli and the rest of them was a kind of deliberate thing, but it was.
I think it was possibly seen as necessary at the time. I think it was possibly even seen as essential at the time. It could even be like the sort of the looming war efforts that were breathing hard down all of their shoulders as well. We have to, again, I think I hear so many people talking about historical context events and completely missing the historical context. But this is the thing, you see, I don't actually see magic is sleight of hand. Yeah. And to some degree, sorcery is sleight of mind.
Yeah.
And so, but this would suggest that means that both of those are mechanisms for tricking people, when in fact, really, they're more illustrative of precisely how plastic the reality that we experience is, and precisely how our realities, how our group realities are a consensus. And that they're arrived at with a consensus, and it only takes the skilled magician on stage to wave his hand in the wrong direction and distract our communal attention to that hand while he pulls the rabbit out of the box with the other hand, that we then see the rabbit as miraculously appearing through magic.
No matter what our intentions were, that's our intentions our expectations being manipulated by somebody whose intent does count.
And somebody who practices that expression of their intent.
And we work a lot better as a group, don't we, even than we do as individuals.
Entirely. Well, yeah, and moreover, that in understanding how reality is constructed as a collective, as a collaborative effort, that any time that you bring any group together from 2 or more people upwards, you begin to plasticize the probability field associated with those individuals. And Sheldrake pointed out that when any... Was it Sheldrake? I think it was Sheldrake, possibly. Pointed out that when any group come together and discuss a subject, and collaborate on that subject, when the group separates, any discovery by any member of that group appears to be instantly transmitted to every other member of the group, and they have the realization without having made the discovery.
Which is amazing, isn't it? I mean, that's
More that in our little group, we had Tamara, who went off and got pregnant and sort of turned off her internet and all the rest of it for the duration of her pregnancy. And when we all kind of met up with her once the baby was born again, it was like she'd been watching over her shoulders the whole time. She knew everything that had been going on.
And that is your spooky action at a distance writ into consciousness.
Mm.
And those
we experience the sensation of being individuated consciousness units. We experience this finger of the handness and not realise that the finger's attached. And I suspect that the reason why this is that because we don't share the same oversoul. I've got a 72 souls theory where the number 72 quite comes into it. I'm not sure, but it certainly appears lots of times in mysticism. In Kabbalism, there's the 72 names of God and various other things, but I didn't actually come up with it from that. And essentially, I suspect that there may be a limited, let's call it a quanta of souls, a quanta of oversouls. And instead of all sharing the same oversoul, that we appear to share a limited number of oversouls. And so we will repeatedly have friends turn up in our lives that are completely unconnected to other people, but appear to be just exactly the same as them.
Yeah.
They might look the same as them. Yeah, well, if you think that if there's 72 souls, that would basically mean that there's 10 million of each of us, I think it works out as, at any given time. Well, the chances of any two of those meeting in a planet of 6 billion people are fairly limited, especially if one could be Chinese and the other one could be English at any given time. And that simply from that one supposition that there appears to be more than one oversoul, and that we are experiencing this individuated consciousness unit purely as an extension of some larger organ of the oversoul of one of these oversouls, that this would also explain things like translocation, astral projection, remote viewing, things like this. You know, I mean, the reason why some remote viewers might hit really well on certain targets is because it just so happens that the guy in Russia or in that nuclear institute happens to be another part of his oversoul.
What an interesting idea. Because, of course, Plato used to believe that there was one soul and we were all an aspect of that.
Well, it may well be that that again, that individuated oversoul may again simply be another fingers of the hand situation where we have 72 oversouls, but they're connected at some higher level to a greater oversoul. Yeah. That's a universal mind of sorts. But I think the individuation is also important. I don't think we would feel so individuated. We wouldn't feel so self. We wouldn't have this strong sense of self and this strong sense of identity and of I'm not you. Yeah. If I stab you with something, I don't hurt. Yeah. And I think that that's possibly important, but it's also important that we realise that if I stab you and you're part of my oversoul, I'm going to hurt in some respect.
Yeah.
We'll start with the flat plane scalar, shall we?
Oh yeah. What's a flat plane scalar?
Right. Well, if reality is fractal, then again we have this inverse square law at play, where we may not be looking at like the inverse square law for light, where it's a fourfold increase, but it will be a magnification. So it will be a fold increase. So it will be either, you know what I mean, 1 times 2, 1 times 3, 1 times 4, 1 times 5, whatever. There'll be a multiplier within that fractal process, so that with each iteration, with each move forward in time, there'll be a much greater series of influences over the next iteration. And effectively, the reason why a lot of our sort of models are either incomplete or inconsistent is because they are scalar models. So the reason why the flat Earth model was thrown out with Copernicus was because by the time of Copernicus, we were beginning to get into global sea travel, and the maps that were made on a flat sheet of paper simply didn't add up. When you put one next to the other one and tried to sail across the ocean between them, you would end up in the wrong place. to this point, the best way that you'll get to grips with this is if you go and look at one of the Ordnance Survey Land Ranger, the sort of walking scale maps, the ones for sort of hillfell walking and stuff like that are really, really sort of small detail. If you look around the edge of those, you'll see a set of numbers of degrees, of fractions of a degree, and they actually change from the top of the page to the bottom of the page and from the left of the page to the right of the page. And essentially what these are doing is it's telling you how far out you are from a compass bearing by the time you get to that point on the map.
Yeah.
So
yeah.
Such that the scale has been so exaggerated by the magnification of the zooming in to a foot scale map from the Ordnance Survey, from the standard Ordnance Survey scale, that essentially the distortion at the edges of the map have become so great because you're taking such a small section of a sphere.
Yeah. Yes, indeed. Mixing your geometries.
And effectively, if you want to map the whole of the globe on a flat piece of paper, you have to do that sort of segmented orange thing that you may have seen, where you have a globe that essentially looks like the segments of an orange sort of opened out and flattened out on the page.
Yeah, yeah. An close approximation, but not the actual thing.
And now, essentially, if let's say you're a structural engineer involved in putting up large buildings. Let's say you're building, a local hypermarket, and you're doing like a 7-floor massive footprint hypermarket. Well, your flat Earth model is an absolutely perfect scalar for that, because essentially the scale of your object on the size of the sphere that you're building it on will not impart any huge inaccuracies when it comes to joining up the corners. Mm-hmm. So you can draw your proposed supermarket, your proposed hypermarket on a piece of flat paper and take the measurements from that piece of paper and have them roughly map to reality. Now, if you're building the San Francisco Bridge, you're in trouble, because your parallel lines on your piece of paper are actually divergent,
which is why people
sectors of a sphere by the time you get to the huge scales of something like the Golden Gate Bridge.
I'm sure we've all seen pictures, haven't we, of people who've decided to build bridges from both ends, and when they get to the middle, they ain't meeting up.
Well, yeah, that was more a matter of the limits of the optical surveying equipment prior to the age of lasers.
Yeah. So you reckon it doesn't happen anymore? Then you reckon all the bridges they build do end up where they're supposed to be?
Oh, absolutely. With the laser age, we essentially have the first time humanity has ever had a dead straight line from any point in space to any other point in space.
Yeah, I had to go with one of those laser theodolites personally. I still like using the one where you use an eyeball and a stick. I think they're a lot more fun.
Yeah, yeah. Well, again, there it's a matter of scale. A prime example is if you're weighing anything, you don't want your scales to be so ridiculously accurate that you're seeing constantly spinning dials. If you're trying to weigh something in a gram, you don't really particularly need your scales to register in milligrams.
Correct.
Yeah, if you're counting up to a gram in an amount, you don't really want to particularly see it in milligrams. Half grams or tenths of a gram is an adequate scalar metric. And again, we're talking about the reduction of complexity. We're talking about the simplification. It's not that those milligrams don't exist and that those numbers aren't wheeling round on an imaginary dial that isn't there on a less sensitive instrument. But it's just that they're not necessary for our particular consideration of that particular measurement. So it's essentially a metric is a measurement. Yeah, a metric is a comparison. Yeah, so any metric is a comparison of one set of parameters against an equivalent set of parameters. So you can't compare up and down with left and right.
Okay, so a scalar metrics would be like millimeters to centimeters and centimeters to meters and meters to kilometers and all of that.
Yeah, that's where the word metric actually comes from. The concept of metric existed in science before the metric system came about.
Yeah.
But the actual the word metric that they adopted meant measurement.
So if you're trying to put up quite a large building, then that's okay. But if you're trying to sail across a sea, which gives you a much bigger footprint than the building has, then you're going to start encountering problems.
Then you have to have a spherical model. And to this extent, the great Buckminster Fuller would often teach his students. He's the inventor of the geodesic dome and the predictor of the existence of carbon-60, like 25, 30 years before it was even seen in a spectral line. And he would teach his students that the sort of the flat plane model was a perfectly appropriate model for the scale on which they would be very likely to be working. But he actually insisted that they completely remodel even their thought and their speech, to the extent of he would insist that all of his students would stop referring to upstairs and downstairs and would refer to them as outstairs and instairs. And he modelled everything from a quadrant of a sphere. Because, again, if you're going to build a building, you need to understand that where your walls are actually pointing isn't in some parallel to the wall next to it, but is in fact pointing a direct line to the centre of the Earth, because that's the direction that gravity acts in.
That's brilliant. Buckminster Fuller did that. That's really breaking the habits of his students, getting them to use completely different phrases.
Well, it essentially changes your scalar metric from the sort of flat Earth model to the spherical model, which is almost completely absent. And in fact, he was adamant that the quadric model, the cubic model of having graph paper that was marked out in squares and of drawing as a flat top-down projection and then doing isographic or isotropic projections from that top-down projection in draftsmanship was in fact leading everybody astray. And that in fact everything needed to be considered from this projection from the centre of a sphere. And that if we were talking on a planetary scale, then we had to consider that to be the centre of the planet. If we were talking about a solar system scale, then we had to be talking about the centre of the sun. If we're talking about a galactic consideration, then it has to be from the centre of the galaxy, and the same all the way down. If we're talking about an atomic consideration, then the R0 is the centre of the the nucleus.
That's wild. Wow, I didn't know. I haven't read them. I did try reading some Buckminster Fuller, but it got me lost. Perhaps I should have another go.
With more than 180 degrees on each side.
It's what? Sorry, say again.
180. Oh no, with greater internal angles than 180 degrees.
What is it?
It's one drawn on a sphere.
Yeah. Yep.
So all triangles, the internal angles add up to 180 degrees unless it's drawn on a sphere, and then it's greater than 180 degrees.
Which pretty much demonstrates the why the navigational models work. The sort of modern navigational models work better than on a sphere than they would if it was flat.
And why the problem with cartography is it has to be factored in at all times into that cartography, that the map maker has to understand that his 2D representation that he's drawing is a metric scalar. Even the very subject of cartography is quite interesting when you take that, because the way that maps are actually drawn is through triangulation. So you're basically taking the highest point in any given locale and looking for the nearest highest point that you can get a straight line of sight reading from, and then triangulating. So you take a reading from that point, and then you go to that point, and you take a reading back to your original point and to a second point, and you go to the second point, and you take a reading back to a third point, and then take a reading back to the second point and the first point, and then you construct your triangle. And from that triangle, all maps are built out in triangles. So again, essentially, like Bucky was saying, with his segment of a sphere.
Yeah, that's how it's actually done.
Well, and when you go up to the top of hills, when you find those triangulation points, on the top of hills. Well, that's specifically what that's for. Those were put there by the Ordnance Survey people to mark that spot as a triangulation point. So you can take that spot as your fixed triangulation point that you can go to on a map and say, there's my fixed point, and survey anywhere in any direction from that and triangulate back to that and have a fixed known point.
That's the same method as I use for marking out difficult shaped gardens. It's actually quite a thorny business. It's really quite difficult to do accurately, I find.
Yeah, areas are they're all right when they're rectangular.
Yeah.
Start getting complicated when they're not so rectangular.
If it's a funny shape round the edge and it's got a slope on it, it introduces all sorts of really, really crazy challenges.
Well, and we're getting into topography, aren't we? And this is another issue again. Is when you look at the surface of the Earth from the context of its 22,000 kilometre diameter. When you take the entire biosphere from the bottoms of the oceans to the tops of the clouds, there's actually barely an undulation. The surface of the Earth would be as smooth as the smallest ball bearing that we can make.
There's another interesting idea to play with.
It's only on our scale that we start to see all the ripples and the undulations and see mountains and troughs and canyons.
I guess the other thing, another very useful illustration perhaps of this kind of metric principle, is the fact that you can measure the outline of the UK on a given scale and map, and you'll get a given answer. But if you actually went down onto the coastline with a 30 centimetre ruler or whatever and measured it, you come up with a completely different answer.
Yeah. In fact, that was in fact one of the bits of maths that led to fractals. Was it? Yeah.
Oh yes.
Yeah, it was actually the problem of measuring the outline of the British Isles and securing the distance that it was around the British Isles, and as you precisely say, it's so crinkly that it's effectively a fractal shape, and the measurement simply wasn't supported by the maths.
So the more closely you measure it, the bigger it gets.
Precisely.
Bit of a challenge, isn't it, for
In
anybody?
Fact, all your mobile phone aerials, the reason why you don't have an aerial poking out the top of your mobile phone was because some clever little git invented the fractal mobile phone aerial. And so every single mobile phone aerial is now a little, how can I describe it?
They used to have a little nub on them.
They did until the fractal aerial was invented. And essentially the fractal aerial is a little printed circuit of copper strips on a insulative wafer. And it goes up, let's say you got the flat track, like in Tron. Yeah, the motorcyclists in Tron.
Yeah.
How they used to be able to turn at 90 degrees.
Yeah.
Yeah, well, it's a bit like that. The track goes along for a little way, and then it turns through 90 degrees. And then it goes X distance, and then it turns through 90 degrees. And then goes X distance and turns through 90 degrees. And it does this according to a fractal algorithm. And subsequently is able to receive every single frequency known to man.
See, that's amazing, isn't it? It just strikes me that some... I wonder how it's decided which ideas get applied and which ones don't, because that shows such an acuity of application which appears to be missing from the kind of general scheme that we were discussing at the beginning of the show.
Well, as far as I know, modern digital communications, all of the sort of mobile phone masts and stuff, all the 4G stuff, is all absolutely dependent on it. Wouldn't have been possible without it.
No. So,
even to be quite honest, I don't even believe in mobile phones. I know how they work, and I don't believe in them.
You don't?
They're magic. There's magic pixies inside. If you knew how small the wattage was being emitted, and all these people's worries about, I've got my mobile phone in my pocket, the wattage that thing is putting out is so tiny. I mean, it's so tiny. If it was a light bulb, you wouldn't be able to see it glowing, sort of wattage. Yeah. And yet somehow this mast that's not even within eyesight, that's got all buildings between you and it, is able to pick up that signal and transceive it into a perfectly audible two-way fully duplex signal. It's just like inconceivable. I feel like I've landed in the future.
You are in the future, Jack. This is it, mate.
Yeah, but I'm still analog.
So being an analog dude, I'm
still out smashing the looms, mate. I think the Jacquard loom was a bad idea. I think we should go back to banging the rocks together myself.
Well, I should think we're going to get back there pretty soon, the way we're going.
Yeah, well, yeah. Isn't it?
So, with the, I'm particularly interested in the business of quintessence, this fifth element out of which all others are made, which kind of was around forever, as far as I can tell, and then was just conveniently disappeared. Do you think, I've seen it recently, I think I wrote to you and said that I'd read a couple of essays recently referring to new ether, spelt NU hyphen ether, which really made me laugh, and I thought, is ether like beards and ponytails making a comeback? I mean, is there actually any ether, do you think?
Accessory to your science.
That's right, yeah.
Ether.
Yeah, new
Go
must...
over your quantum, your quantum bling.
New must have 10 kilo pack. So do you think there's ether in the end? Do you think it's there?
That way. Well, I mean, ether essentially was fundamental to Maxwell's equations. I was just mentioning to you in the break that Faraday's laws of electromagnetism rely on many of the foundations established through Maxwell's work. Maxwell's work was a work of towering genius and was of unbelievably, unfathomably complex maths. And it essentially took a genius like Faraday to decode that maths into something a bit better. And I think it was actually somebody else that actually rephrased Maxwell's equations into something more useful and serviceable, which has gone on to create the electronics revolution that we get. However, the Faraday's law that we're given, as we're taught it in the sciences, we're taught it through this left hand and right hand model, where we're invited to point our index finger from a clenched hand, and then point our middle finger at 90 degrees to our index finger, so stick our middle finger out at 90 degrees, sort of poking out from our palm, and stick our thumb up in the air.
Yeah. And
this essentially tells you your force vectors that will tell you which way your motor will spin according to which way the electricity is travelling through your wire. And all electronics and all electrical motors, all electrical generation absolutely is fundamentally dependent on the left hand and the right hand rules of Faraday's law.
I remember that.
However, in Maxwell's original writings, there was a fourth vector. And this fourth vector was infinitesimally small, but it was pointing in the opposite direction to any of the other three. It was not an equal and opposite, but it was a tangentially opposite force that was a co-vectorial, a counter-vectorial of the addition of all of the other vectors, and effectively constituted what would have been an etheric drag. And there's been quite a lot of experiments, even up to the modern day, trying to calculate and evaluate the actual factor of etheric drag. Maxwell theorized it, but it's never actually been able to be measured. It's so small an effect.
And it's but presumably the small effects seem to me, for a start off, to be the ones that are most significant. And given that everything is basically a whirling, spinning mass of energy that's being dragged through space, we can expect an element of drag. I mean, is this distinctly interfered with current physical theory? Do you think this absence?
Well, I think one of the, orbital mechanics was one of the things that sort of disputed the etheric drag. That essentially orbital mechanics would grind to a halt if the ether was purely a resistive force. So if it did nothing but get in the way of other things trying to move it, and acted essentially like a non-physical friction.
Surely it's the kind of...
Eventually all solar systems would grind to a halt and the planets would stop orbiting.
Okay, that sounds pretty serious.
So that was one of the reasons why ether began to be discredited, was because it couldn't be modelled in.
Right.
And I would suggest that, again, this is because of the misappropriating of the word force into Newton's gravity. that Newton's gravity and celestial mechanics were absolutely undeniable. His calculus perfectly matched the models. Halley made his predictions of the return of Halley's comet through the understanding of calculus, and was able to calculate, the return of this celestial body that was only seen once in a blue moon to within a day or so of when it actually arrived, which was previously completely impossible.
They'd have burnt him at the stake in earlier ages.
Well,
or given him a job as a priest.
Exactly. And so the power of Newtonian mechanics and celestial mechanics and the effect of calculus on all of the consideration of those is not to be underestimated. However, it's this refusal to question, and it's this adoption of gravity as this mysterious force that we then now end up with the bloody Higgs boson.
Oh, they've got one, apparently.
Yeah, no, they got two. They didn't find one, they found two. Yeah, no, apparently this Higgs boson that would be identified by a nice, clearly defined spike at this particular electron volt, this particular point on the electron volt scale has been agreed to exist. But, it showed up in two places.
Aha.
They put that down to noise in the machine.
Oh, well, yes, indeed. Yeah, I know what they mean.
Our calibration is a bit off. I
have that problem all the time.
I was actually listening back to the Tom Campbell, because I'm doing this holographic reality show. I was listening back to the interview with Tom Campbell. I remember saying to him about the ultimate conclusion of the Hadron Collider's search for the Higgs boson will be exactly as meaningful as finding out the precise mass of your Sims character.
That is a really nice little metaphor. I like that.
But we'll know it to 100 digits of precision.
Yeah. Well, one of the things that seems to be steering their search for these ever smaller particles or whatever is the use of kind of multi-dimensional models where they kind of spin things through 12 dimensions and then look for the gap in the pattern, and
relies on at least 11 dimensions.
Well, and I remember you saying last time we spoke that we have no need for any more than the 4 dimensions we've got, which are the 3 dimensions of space and the.
And moreover, any other are impossible within the reality is 3-dimensional plus the arrow of time.
See, that's really great, isn't it?
Because that is not real by its very definition.
Yeah, one of the things I like about your theories is that they're pointing centrewards towards simplicity rather than outwards to ever greater complexity.
Well, like I said to you in the sort of preamble before the show, that what we're talking about here is, in fact, the modern science has become something that I have stolen the word from. What's his name? Irish guy. Eludes me. Anyway, I've stolen the word mysterium from somebody else who probably coined it from somebody else as well. But I think that the whole of the sort of scientific dogma, the whole of the scientific establishment has become this enormous mysterium, this enormous cult of the mysterious.
Do you think that's what the scientists...
We have celebrities of the mysterium. We have the Brian fucking Cox, excuse me.
Yeah.
And the what's the geezer out in America? Can't remember either. Tyson, Neil deGrasse Tyson, and these mouthpieces of the mysterium. And their explicit purpose of being paraded in front of the media appears to be to mystify everything to such an extent that people are completely convinced that the scientists have now essentially settled science, and it's more peculiar than we could ever imagine.
I did see once a book which was something like, "Are there any questions left to answer?"
Yeah, anybody at the back got any questions?
The thing is that we might be we might be being presented with the mysterium, but the drive of scientists
relies on
the drive of scientists is surely not to be engaged in that, but to actually discover things. There must be a huge sort of underbelly So another question that's been somewhat bugging me for actually a couple of years since I started talking to you about these things is if not the Big Bang, then what?
Numerical flux.
Yeah.
Numerical flux and the evolution through the dimensions from probably a non-dimensional to the quadridimensional that we have today.
Right.
So it's entirely possible that we may evolve additional dimensions, but I don't think they exist currently.
Maybe what we're working at now, I've heard that as a theory, that, you know, the third dimension is the gateway to all the others, but at the moment the gate is closed.
Mm.
And certainly once you start thinking about what you're describing as the human entity and what it's capable of, and neural plasticity and all of that, once you attach it to a kind of global computer, you're already starting to deal in dimensions that are a little bit weirder than what we're used to.
Absolutely. I mean, the sort of the global mind thing as well. It's really very hard to kind of to separate this appearance of human, the sort of specialty of human consciousness, but the importance of our sensation of other awarenesses, other lower orders of awareness, and that knowing that how everything's fractal, that just makes me think that everything is consciousness, that the planet that we stand on, that the sun that we orbit, that the galaxy that we live in is somehow some sort of supra consciousness, and that what we're actually experiencing is some kind of a geometric standing wave in that greater consciousness set, and this is essentially what we're experiencing as reality. The computational surface on which we experience the computational surface that we experience as reality is effectively the sort of standing waves in the thoughts of this sort of supra mind, this galactic mind or universal mind.
One huge single vibration.
No, which would effectively make us like synapses. You know what I mean? We'd be the input-output terminals of a greater mind.
Yeah. So, I mean, naught-dimensional space, that's quite a difficult idea to get your head around. It's this whole unbelievably massive thing started as absolutely nothing in nowhere.
Well, again, you see, even this thing of the massiveness of space is only down to redshift.
It kind of occurred to me just as I was saying it. I thought I'm going to have my balls chewed for that one.
We covered this on New Year, that the actual only observations that we've got that actually place any extrasolar objects at a known distance is those that have been taken by parallax, and that's because they're effectively, again, this triangulation. So by taking an observation in, say, summer equinox and winter equinox, you're at two 180-degree polar opposites of the sun, and are of a known orbital distance between. So there's your base of your triangle, the gap between the Earth at summer and winter. And then you take an observation of a star and you triangulate between those two, and then you observe any star's movement in front of or behind the observation of that star, and you can you can triangulate between those 2 points and calculate the actual points in space that those two objects occupy.
Yeah.
And essentially that can only be achieved up to, I think it's not even 50, I think it's 50 light years. So the only universe that we've actually mapped through triangulation, through anything that we can actually be certain of distance wise, is the very local area of the galaxy.
Well, doesn't that give us potentially significant problems with distant objects that we've found hard to identify, things like pulsars and quasars, and
the huge Crab Nebula galaxies and things like this that we're given as billions of light years across may be very, very small and very, very close.
Right. So it might be like was it Spike Milligan who said the sky's full of holes where the rain gets in, and the holes are very small, which is why the rain's thin. We were talking about Isaac Asimov last time we were chatting, and I've been reading a book by him called Exploding Stars, And it's basically about the development of the telescope and how we found more and more stuff the further and further we could look. And Jimmy, I think it was, put a question into the chat box saying, how do pulsars fit in on galactic scales? And I find myself wondering just how accurate we are on things like pulsars and quasars.
Completely inaccurate.
Right.
Completely. There's nothing there that we can actually call a metric yet.
Right. So wow, really?
The reason
so
why
disappointing.
pulsars are credited with this enormous power is because they're conceived as being incredibly far away. Again, they may be very local. They may even be just outside the solar system, because if all we've measured them with is redshift, then we don't know where they are.
And like you're saying, out beyond a given point, we have only measured things with redshift.
Yeah. Anything beyond, I think it's 50,000 light years. 50 light years.
Excuse me, was that the rug just being pulled from under our feet? Was it? So, yeah, at that very beginning point from non-dimensional space, we're imagining simply on and on-off state of some sort starting to become on and off.
The fact that fluxation may be the basically the initial miracle. If my theory has a give me one miracle and I'll explain you the rest, then why everything should be in persistent fluxation at every level is probably the only inexplicable part. And it may just simply be it may just be that is the rule, along with beneficence and obsolescence. So it would appear that if you combine fluxation, natural fluxation, so the natural desire for two coincident areas of space or areas of matter to desire not to occupy exactly the same state. So if one's positive, the one next to it will go negative. If one's hot, the one next to it will get cold. And that this just appears to be the state of nature, that this appears to be what the stuff of reality is made from, is two assumptions of fluxation and of beneficence and obsolescence being the anti-entropic arrow. The anti-entropic directional arrow. So generally speaking, things are seen to be moving from hot and simple to cold and complex, but there also appears to be this counter force, this anti-entropic force, which appears to be this kind of beneficence, this preference for beneficence. Evolution, nothing, solar, galactic, planetary, biology, computer, every sort of evolutionary track that you can possibly track would be impossible without the action of beneficence being preferred and obsolescence being eroded.
So the cosmos really is on our side.
It's on the side. If you happen to be on the side of going in the direction of beneficence and moving away from obsolescence, then it appears to benefit your trajectory. It appears to grease your wheels, and that I would suggest is what happened with those synchronicities in that video clip.
Yep, and as observed, that principle works right the way down to kind of human relations.
And moreover, the all of the principles of the philosophy that I'm sort of projecting were all encapsulated into the doing of the show, the talking of the show, of the recording of it, of the creating of the video. So we've got kind of a fractal compression going on so many different levels that effectively that work was a work of a fractal scalar. Yeah,
there was something else going on.
And again, this is kind of muse thing. This isn't. Everybody keeps pointing to me and going, "You're saying this." Well, yeah, the words are coming out of my mouth, but they're largely unbidden and don't appear to be particularly of or from me. They appear to be coming through me. I feel like a conduit. I feel like a pipe with something coming out, and it's not coming out of me. It's going through me.
It's kind of characteristic of something you said when we last spoke was. chaos appears to fall out of the process fractal iterations regardless of what the initiating state is. So do you think there's an actual kind of movement towards order rather than chaos?
Well, again, I would suggest that in that Rule 23 process fractal, where the chaos begins to look very organic, I would suggest that that's, again, an oversimplification, and what you're not seeing there would be the invisible anti-entropic force that would be going in the other direction,
right?
The counter-rotating toroid. So essentially, with those process fractals, with the pyramid, with the triangle, the two-dimensional triangle that you're seeing of that process fractal in nature, that would actually be the outward sort of funnel of that co-joined, counter-rotating bitoroidal structure that you'll see all the way through that video sequence from the primer fields video.
Yeah.
Where you have the two donut-shaped vortices connected through their central point and meeting at a foci, a focus in the middle, and it basically explains stars and planets and atoms and why everything's spherical and why everything appears to have an energetic flow that appears to adhere to a geometric structure, and that geometric structure appears to be defined by the 5 EBM array, by Marco's work, Marco Rodin's work that Vid interviewed that time.
Yeah. So you basically got, instead of this...
So insane that you couldn't answer any of my bloody questions. Man's lost the plot. Why is it that all these people, they get a fragment of this? They get a fragment of this and they see deity.
Yeah. Or they wonder...
They don't have the whole model, because they don't have all the rest of it, because they've just found their one bit, and it's like, wow, look at this. And then when they sort of stand back and sort of marvel at it, they think, well, how the bloody hell can that exist? And end up having to resort back to their Judeo-Christian kind of paradigm, or their tyrannic Kabbalistic philosophies, in order to construct some sort of semblance of sense out of what it is that they've stumbled upon.
And yet what we're talking about is basically an on and off state and a rule, a signal of some sort. And then it just happens.
I'm not entirely sure that the digital part of the I think that binary is possibly, again, it's useful to think in terms of computers, and it's useful to think in terms of data being transmitted digitally, and digitally being a succession of on-off states. But I think that it's entirely possible that the actual data stream itself may be effectively three-dimensional. And so to break it down to a string of on-offs is probably doing it a huge injustice. And while each information packet may be an on-off state, that the way that we receive them is in a three-dimensional matrix. And so those data streams are coming in from all directions and essentially interfere. And the reality that we perceive is that standing interference pattern, the standing wave in the background fluctuations.
Right. So it's basically a system exchanging information with itself.
And the only way that, I mean, you kind of can go to some of the sort of Zen Buddhists and how creation, the creation myth in Zen Buddhism is that the monad kind of got bored.
Yeah.
Because it didn't have anything to do.
Nobody to talk to.
So it'd have somebody to talk to.
Yeah.
And thus was created the universe.
Yeah.
And so, yeah, we have this. We certainly appear to live in a dualistic state of positives and negatives, and norths and souths, and hot and colds, and the nature of reality as we experience it appears to be the spiraling vortexes and the interplay of the emanating fields from those spiraling vortexes. That the interplay of those fields, forces, and rotations are what generate the sort of interlacing field that creates the hologram that we think of as reality.
It strikes me what your description just there really reminded me of was the human endocrine system. and how it is that several different organs produce many different chemicals and signal transmitters and stuff actually in real time, kind of vibrationally. Nobody seems to really understand how it is that one endocrine organ produces a load of responses to a second a primary endocrine organ. But
well, funnily enough, there's a scientist currently making an awful lot of money by creating novel scent molecules, by predicting what they're going to smell like by their electrical properties. And he's also done a lot of research into the action of nearly all of the psychotropic drugs, including all the sort of medicines and their action. And it would appear that something like the action of a benzodiazepine in the whatever it is receptor that it fits in the brain is not just because it's a key in a lock, which is the sort of chemical model that we were always given before, but that in fact it's a wire it's a plug in a socket. Right.
So it's more like a telephone exchange.
Yeah. And it essentially completes that circuit.
And so all of that's electrical as well. And I know you don't, because you're concentrating, aren't you, on annual plants, because they're going to be the basic simple model. And I know you don't.
That's really what I've maintained that for the electrobiology model, just simply for the mapping.
It's giving you a benchmark, isn't it?
Yeah. But certainly all of the mapping across that I've done to animal biology appears to be absolutely upheld.
Well, that's the thing, is that
from why your teeth get rotten to why cancer and why this and why that.
Well, I mean,
disease itself. I mean, the virus essentially has the opposite electrical charge to your system and soaks up all your electrons.
It's everything, isn't it? Because
that's why vitamin C defeats certain viruses, is because vitamin C will replace the electrons that are being soaked up. And essentially the reason why the massive doses of vitamin C appear to work, whereas sometimes if you take too little, you'll often feel worse, is because the viruses will quite happily feed on the extra electrons that you're giving them with the vitamin C, unless you put so much in that you're able to basically flood the system and reverse the polarity of your entire body in such a way that it's too much for them.
Right, and also I suppose because I found the vitamin
called the ATP cycle in every single cell, the production of the energy from sugars, so the electrical energy, the conversion of sugars into electrical energy that the cell can use, is done through something called the ATP cycle, which is using the ATP molecule, and the ATP molecule is responsible for tearing apart vitamin C. And in the presence of adequate vitamin C, one ATP cycle produces 2 units of energy, whereas in a deficit of vitamin C, it'll only produce the 1, which is why you feel lethargic, why scurvy makes you feel tired.
I have found the vitamin C to have been the most amazing thing. Actually, I've been swallowing.
I don't touch it with a barge pole personally. I don't eat any citric fruits. I have nothing at all to do with vitamin C. I'm a picked.
I'm just taking the vitamin C because it was yielding loads of problems.
Yeah, that's because you're a Celt.
Oh, right.
See, I'm native to this land. You Nordic type. You invaders. Yeah. I live on nuts and berries, me.
Yeah, well, I probably would do if I could chew them. I'm probably going to be missing.
Well, there you go. I mean, there you go. Tooth bacteria, the bacteria that dissolve your teeth. Dissolve your teeth because they're the opposite polarity to your natural tooth bacteria and to your natural tooth polarity.
Well, I think
they literally electrically erode your teeth.
I think I'm in some sort. Well, indeed, like the sun and a comet, which is where we're going to go next.
Mm-hmm.
I've got a question from Jimmy in the chat box.
How about that for starters? No, go on, question.
Yeah. Is Jack aware, says Jimmy, that redshift has been observed on incoming comets due to release of X-rays?
Again, the understanding of redshift has to be questioned as being velocity. And the only reasonable alternative that's being offered other than velocity is the energetic state of the quantum upshift of the electron. Again, having to refer slightly to quantum theory here, but a photon is released when the electron returns from a higher state, energetic state, from an outer ring, and it jumps back down to a lower ring. And as it jumps down to the lower ring, it has to release a packet of energy, and that packet of energy is what we call a photon.
Yeah.
And so where was I going with that? So essentially the energetic state of the atom that released the photon affects the colour of the photon that's emitted. And so we tend to see that lower order energy states put out red light, and higher order energy states put out blue light, as can be seen by electric arcs and flames. And if your flame's burning well, it's bright blue. If it's burning badly, it's yellow. Blue indicates hot, yellow indicates cold.
Oh.
So essentially the colour of the light as it's being received from the comet as it enters the solar system, it's going to be subject to a bow shock, an electromagnetic bow shock.
Yeah.
That's going to raise the energetic exchanges, the thing that's... Well, again, how are X-rays coming off a bloody comet? How's a comet emitting in the X-ray? Well, the only thing that emits in X-ray is things that are subject to huge electrical forces or are radioactive.
Yeah. So
it has to be hugely radioactive to emit X-rays to a degree that we'd be able to read them on Earth.
Which isn't
so
what...
if there's X-rays coming in from comets, there we go. We might as well go there. The sun's hollow. There's nothing in there. There's no sun in the sun. There's just a big ball of plasma. And that plasma is electrical. And it's this bi-rotating toroidal structure with its two inner surfaces extruded to meet in a center, in a co-joined center. And at the point of that co-joined center of the two counter-rotating bitoroidal structures, or the counter-rotating bitoroidal structure, is what we know as a sun. And so what you have is these two enormous donuts extending far out into space and essentially gathering and recirculating the galactic electrical energy that's simply harvested by the motion through the heavens. It could be etheric, or it could simply be electromagnetic. I mean, we could simply be talking about a big electromagnetic effect here. We've got a galaxy that's a huge electromagnetic effect, and so it may just simply be like the galaxy is just like a huge electric motor that moving a conductor through a magnetic field is going to induce a current. And so what we see as a sun is literally just the visible sign of that induced current being focused about an intensely small point in space. And as we can see from the primer fields, we might as well refer to them here. If anybody wants to see this in action, you can go to the original videos that I used in my animated Electricity, the Universe and Everything animation video. And if you go to the original primer fields, you'll see this chap who's basically developed these two magnetic bowls, where the inside of the bowl is one magnetic pole and the outside of the bowl is the other magnetic pole. So they're basically like a bar magnet, but curved into the shape of a bowl and with a hole in the middle.
Yeah.
And he's got one set that's a north pole on the outside and a south pole on the inside, and another set that's a south pole on the outside and a north pole on the inside. And by bringing these two magnets into close proximity, but with an air gap in a bell jar that's been evacuated, so a partial vacuum in a bell jar, and then introducing into a cathode and an anode held above and below the outside of the bowls, he's able to focus that electrical plasma to such a point that he effectively creates a sun in his living room. And you've got this sort of golf ball-sized sun suddenly appears between these two balls, and you don't really need any more bloody explanation.
Those primer fields videos are utterly amazing. So
they explain atomic structure, electron rings. You can see it all in there. Those two magnetic fields basically describe everything that we know to rotate.
Loads of geometry too.
And that's why the primary video that gets repeated almost on a loop all the way through the back of my... If you can get those primer fields, if you can understand those primer fields videos, and you don't really need to understand them, because when you see them, it's self-evident. He shows you what the shape of the fields are that his bowls create, and then he shows you the bowls, and then he puts them in the bell jar, and then he evacuates the air, and then he applies a voltage. And actually, there's one little key bit in that I wish I'd lifted, because there's actually one where he separates the bowls, and you see, our red sprite video, our electricity or biology video that I put up with the huge 60-kilometre tall red lightning sprites.
Yeah, beautiful.
Looking like trees.
Amazing.
Well, he actually ends up with a structure that's almost identical to that. And what colour is it? It's red. He separates the two magnets out, and instead of having that bright, intense ball in the middle, which is exactly what I'm saying biology does, that the two fields separate, and that's why we see a trunk. You see a perfect thick trunk appear, and above the balls you see a big branching structure that looks like a canopy, and the lower structure goes out and is much more diffuse and looks much more like a root structure, but it's only on screen for a few tenths of a second, just while he's like fiddling around with the bowls to get them just right for the sun effect. So again, he stumbled across that and he's like, wow, atoms, suns, wow, and then missed the fact that he also explained a tree.
Yeah, or a brain.
Or a brain, or a lung, or a kidney.
Yeah.
Or a dividing cell, or a lightning strike, or...
So I thought I understood you from one of our earlier discussions to say that magnetism arises when there is a current flowing.
Not quite. That's how magnetism arises in a electrical circuit. However, the exact same effect is effectively frozen into a magnet because of the electrical properties of the crystalline structure of the magnetite or whatever the magnetic material is.
Yeah.
So essentially the electron dipole is frozen is locked into the magnetic structure because of the crystalline structure of the material.
Right.
So essentially the shape of the crystal and the asymmetry, the polarized asymmetry of the crystalline structure of the dendritic structure of the metal, or the crystalline structure of the ceramic, like the neodymiums and all these sort of magnets. Well, essentially, as you're creating the magnet, you'll have to induce the magnetic field into it on the point of creation. And then essentially, once that's been created, that is frozen into the crystalline structure and remains there essentially for time immemorial. Mm-hmm. It doesn't, but it's as near as damn it.
Because his magnets.
And again, and also you can magnetize things like steel, but it's a much more transient effect. You can magnetize an iron nail with any big magnet or with an electromagnet, so it becomes a permanent magnet. But it's not really a permanent magnet because that magnetism kind of fades. And if you bang the thing with a hammer or bash it on the bench, it stops being magnetic.
Mm-hmm. Just like that.
So basically you've put the energy in to reorder all the electrons.
Yeah. And
now they're random again.
So he's used some pretty clever technology to make those magnets of his.
I should imagine they're actually quite straightforward to make. It would just be a matter of how you magnetise them. You would need to magnetise them over a kind of some sort of a ball Gauss.
Yeah.
What would that be? It wouldn't be a Gauss meter, would it? It would be I don't know, whatever you put Gauss into things with. Put her in.
He does. I love one of my favourite bits. We're coming close to the end now. It's already it's coming up to midnight. One of the things that I really enjoyed about those videos, the scene I remember best was when he kind of lodged a ball bearing into the little hole in the bottom of the cups, and then shot those 3 cans off the edge of the desk that said dark matter, dark energy, and black holes on them.
Yeah, I'm really digging for that.
So it is just kind of all stored up in these little magnetic cups.
And moreover, those balls aren't even actually held. There's no physical retention in those magnets. I don't know if you realise that, but when he's firing those ball bearings through there, those balls are actually hovering in midair before he pings them out.
Yes, I had noticed that. They're actually held in the magnetic field themselves, aren't they? I've got a quick biology question.
It's members' tunes, isn't it, after you?
It is members' tunes after me, indeed.
I feel that Tony won't object if we drift a few seconds into his members' tunes.
I don't like to get my wrist slapped. I'm sure he'll let us.
I know,
but... I wanted to ask...
Right, we'll be sorting Tony out. He's coming round. He only lives in Southend.
Oh, right, okay. Well,
You know, Tony's going to be sweet as
that's
soon
right.
as he's been here, won't he?
He won't be causing us any trouble then.
He'll be part of the tribe then.
I wondered if in your investigation of plants and things, and seedlings especially, whether you come to any conclusions as to why it is that all plants put out those little cotyledon leaves, you know, those little leaves that they put out before they're proper leaves. Every single seedling basically has these little leaves that haven't got any lobes on them or anything. They're more or less
like
oval.
cusp leaves, aren't they? They sort of hold the growing tip.
That's right, and they all have them. They all look very similar, although they are in fact all unique. Even though all of these leaves for all of these plants are broadly the same shape, they're actually all identifiable. I'm wondering whether you'd come to any conclusion as to why the plant does that.
I've not really thought greatly about that, but certainly that particular point in plant development is absolutely key, and I'd invite anybody to go and watch all of the time-lapse videos that they can of seeds germination and study them. Put them on slow-mo, YouTube. You can now slow-mo stuff. I don't know if you know that, but in the settings you can dial up like a 25th, you know, a 0.25 speed, which allows you to slow-mo everything.
Oh, right, I didn't know that.
And you can sort of speed up and slow down at leisure, sort of thing. And if you watch those seed germination videos, there's a real key observation as the canopy is being lifted out of the seed, and the mechanics. If you imagine yourself down on that scale, the effort the plant is achieving to raise those first leaves out from the seed pod and push them up through the soil and push them up into the air. It's very hard to imagine a mechanical explanation that would describe how the plant could do that from just simply applying the force from within. Often there are like sort of necked points in the stalk that would be a mechanical weak point. With the amount of leverage that's being applied on that point in any conventional system, that would be your failure point. And every single seed with that little necking point in it would just fail at that point every time, and yet they don't. And even despite that apparent sort of fundamental engineering weakness, they still appear to be able to raise these enormous lever forces and elevate the crown. And of course, the first thing they do is the leaves separate. And why do the leaves separate and separate to sort of 30 degrees initially? Because that's charge separation. Both of the tips are positive.
Yeah, and it does that. It does that straight away as soon as it comes out the surface of the soil.
I employ. I mean, there's two simple. If everybody finds my 3-hour stuff just too much to bear, go to my Omniversity, or I think I actually put them up on both, but definitely on the Omniversity. Go and look up electricity or biology ? And biology or electricity ? They're two little 9-minute or 10-minute vids. They've just got music in the background, so you don't even listen to me droning on. You can just witness the evidence of your own eyes. One of them is presenting electricity that looks exactly like biology, and the other one is presenting biology that looks exactly like electricity.
And then when you consider the kind of levels of denial that must be out in the scientific field to have not looked at this before, you can then go and have a look at the thunderbolts.
Well, no, funnily enough, again, I find myself coming to the conclusion that it's firstly that this is the first period in man's history. Those red sprites, first of all, they were only discovered 10 years ago for the first time ever.
Yeah,
nobody
okay,
had ever
I
seen
see where
those.
you're going.
Essentially, the advent of the high resolution, fast acting CCD chip cameras, and somebody happened to be taking a photograph from across a desert, from a great distance, of a thunderstorm, and they're actually taking the lightning strikes under the cloud, but they got a significant portion of above the cloud, and they just happened to take the shot. Those red sprites are actually in existence for like a hundredth of a second or less.
Yeah.
So if you don't take the picture at that precise moment, you'll never see them.
That was great, wasn't it? You got a human being with his.
Who've been flying over clouds all their lives.
Yeah.
Have never known that they've seen them because there's such an instantaneous thing that if you're not looking directly at them when they happen, you won't see them. And because they're such high altitude, low current, I think, effects, the actual amount of photons that they're releasing is intensely small. All of that photography that you see in those videos is of the highest order CCD. That some of those images, those specific images in that Electricity or Biology, are the red sprites. That's I think it's a 10,000 frames a second high resolution mono camera. It has to be in black and white because the frames per second are so fast that the wavelength of light can no longer be received by the CCD, so it can only receive either light or dark.
And it's got a bloke peering out the window of the aeroplane with his finger on a button. He's got to press the button.
And then I took that footage and I slowed it by a further factor of a tenth.
Right.
Yeah, so to what you're actually seeing on screen, and some of those things blink on screen and blink off. That's not me speeding it up. That's slowed down by 10 times.
And it's not just that, is it? Because you were saying, I think, that we wouldn't have been able to measure.
Just to quickly point out, these red sprites effectively exactly describe what I've been saying is true of trees, and what you can actually see in these red sprite images is a picture of what looked to me perfect oaks or beeches.
Yeah.
That you have the canopy, you've got the fluffy canopy, you've got the perfect branching structure that isn't an exact Fibonacci, it's not an exact fire, but it's roughly approximate, coming down to a central trunk, going to an effective ground level, and then below a certain point you get an entirely different structure that takes on the absolute appearance of roots. And when you see multiples of them going off, sometimes you get sort of 5 or 10 of them go off in a group, and they look exactly like if you were to see like a little hillock with a clump of trees on it. It would look exactly like that if you could make the ground go invisible.
Yeah, yeah, and it's not just that, is it? Because you were saying also that the digital multimeters that we've got now, that's the first time we've been able to do the work that you've been doing. We wouldn't have been able to do it.
And the biology or electricity video there, nearly all of the images that you're seeing there are images that have only been possible in the last 10 years.
So it's not denial. It's
like the hyphal, the hyphal fungi growing in real time.
Yeah.
That just simply wasn't able to be imaged 10 years ago. That's again another CCD revolution. All of those mouse cells that are fluxing and twitching and doing all sorts of weirdness. Again, that's not actually a picture. And that's a computer tomography microscope. But if you'd put the organism under an electron microscope, it'd kill it with the radiation.
Yeah.
So it's these novel imaging techniques that are beginning to reveal this view of the world where before, to see something under an electron microscope, it had to be dead. Mm-hmm. Whereas now we've got these new imaging techniques where we're able to see those things that we were marvelling at under the electron microscope. Yeah. Wow! I mean, look at what the world looks like down there.
See living critters lighting up,
alive, and they're incredible. Yeah. The speed at which things happen, it's just like lightning. It's not biology down at that scale.
I'd be very interested to see whether the advent of all of this technology to enable us to do the things that we couldn't do before will actually encourage people to do that, because the way I was going with it was to say that NASA have done loads of experiments that have proved to themselves undoubtedly that comets are actually lumps of exoplanets, and that they are actually involved in an electrical interchange with the sun as they come into the solar system, but they seem to be absolutely flat denying this and just not willing to look at it. So I'm wondering if they're going to...
I would extend that further. I mean, we were discussing this earlier again before the show, weren't we? And I would suggest that same thing that you're seeing there with the sun, we've probably got exactly the same in the middle of the Earth, only of a much lower order of electrical magnitude.
Right,
and so where the sun blows off all of the matter that it makes, so all of the atoms that the sun is creating with these enormous electric fields. This is the other thing we haven't even covered, that that suns are the creators of atoms. That by bringing about this focus of electrical energy about such a tiny point in space, there's nothing that we can imagine. There's nothing in our physics that would allow us to experimentally prove this. But the suggestion is that amount of voltage, that amount of current passing through such a small point in space is actually what's generating atoms. And the reason why we see hydrogen and helium in the sun is because it's literally being made there.
Right, brilliant. And then
made on the surface.
And then somewhere a bit further.
And that what we could be seeing with planets, and especially with rocky planets like the one that we live on, is that same thing where the sun is creating hydrogen and helium and blowing it off. Well, it may well be that if you've got a lower order of magnitude energy travelling through, that you'll end up with more dense objects and that they won't be blown off because there's not that kind of radiant energy coming out to push it all away all the time. And so it accrues on the surface or around the surface of the extent of the sort of spherical energy field that must be in the core of the planet.
So then you'd start getting heavier elements as well.
Oh, and the planet's got to be hollow as well.
Oh, brilliant! Yeah, I'm definitely a hollow earther.
Hollow. It's essentially the centre of the Earth, the centre of any spherical gravitational object. The centre of that object has zero gravity because the forces are all acting in all directions in equilibrium.
That's funny, because I once heard Carl Sagan say that it's impossible to have a hollow satellite. Are we suggesting that they might all be hollow?
Well, they have to be. They have to be.
Round of applause. I love that.
And simply because of this, because as the spherical object grows, the centre will have exactly the same zero gravity as the outside, and so the accruing of mass will be from the inside out as well as from the outside in.
A balanced flow of energies in both directions, as we are coming to expect from your work, really.
Which could mean that the hollow Earth theories, with there being an inner Earth with an inner sun, may not be entire bunk, which is even creepier for me to think about, because I thought I'd thrown that one away years ago.
Well, that's absolutely great, Jack. I think that's
no reason at all why there couldn't be another surface on the inside of the sphere, and with that primer field sun thing going on in the middle, but of a much smaller magnitude of our sun, being of an intensity that would be tolerable to the Denzians on the surface of the inner sphere. So and there may be another bloody planet, effectively another.
Oh, yeah, indeed, a whole load
on the inside, which is
a whole load of kind of different laminar flows, just like we see in water and just like we see in the air, but under the ground beneath us.
Oh, yeah, that as well.
Well, I think that's a cool and fruity place to stop, matey. And we have made it through most of my notes and most of my questions. I've still got
Do you feel like you grok it better at this point?
I certainly do. Thank you very much. Yes, it's cleared up a few things that I didn't.
I hadn't. Robert Heinlein quoted there. And everybody should read Heinlein's
Stranger in a Strange Land.
Strange Land, which is where that word grok actually comes from.
I actually should read that one again. You're quite right. That was a very formative book, and that is one that I think.
A fabulous audiobook. There's a beautiful audiobook of Robert Heinlein, Stranger in a Strange Land. I think it's about 5 hours in duration, beautifully acted. Really, I think it's verbatim to the book.
Brilliant. Well,
word for word, and really excellently acted as well. Really transportational.
Well, we'll give that one a look, because
you're really, even though it's an audio book, it's one of those that you just get entirely sucked into. So anybody like me that's dyslexic, struggles with words on a page, go to Robert A. Heinlein, Stranger in a Strange Land audio book on YouTube. You'll find it there, 5 hours long. It's wonderful. Go listen to it.
And you're bound to understand it, because we definitely all are strangers in a strange land, and it's getting stranger.
You love the Jubal character as well, who won't do business with any persons.
Yes. Oh, right. Yeah, definitely. Okay.
Robert was trying to teach us something.
I think he might have been there. I've been a few of them out there, haven't there?
Right, should we let Tony on for some tunes and I'll slide over?
Absolutely brilliant, Jack.
It's fabulous as usual, Nick. My day has been so frantic, and the last few days have been so frenetic. And with Ojar and Nicole turning up just as we were about to come on air, I was feeling a little reticent about having said yes. Especially as I was asleep for up to about 2 minutes to 9, having come home and passed out.
No, you did really well. I really enjoyed that, and I will
recovered my senses just in time to
once I've got
all of this once more. You certainly have the effect of dragging me out of myself.
Great. Well, once I'll keep an eye on the chat rooms and your developments and stuff, and once I've got another couple of pages of questions, I'll call you back again, because I always really enjoy it as well. It's been, for me, it's been this particular interchange and the last show, the New Year's Eve show, have been genuinely mind-changing, really, really enlivening interchanges, I think, and I've thoroughly enjoyed it. And I
think that's why it's so infectious, is simply because we're all feeling the same thing about it, and I'm not prissy about it and claiming any sort of ownership. This is something that this is like a discovery, not an invention.
Yeah, totally brilliant. So you've all been listening to Dr. Rock chatting with the totally inimitable Freeman Jack on peoplesinternetradio.com. Thank you very much, Jack, for being there for me.
You're welcome.
And for everybody for listening. Coming up next
Thank you all for listening as well. Yeah, you're most kind in listening to my rambling old goatness.
Well, I'm listening to all your podcasts and stuff, and there's plenty of questions arising, mate. So more of this to come, hopefully. In the meantime, I'm going...
1 a.m. Friday, people. 1 a.m. Saturday morning after Uniquely, dark side of the room.
Strictly podcast material.
Reality theory.
Strictly podcast material as far as I'm concerned, because I very rarely make it past 11 o'clock.
Podcast hour in the day. I don't get many people in the chat at that hour, I can tell you. The ones that do stay with me are hardcore. They listen to every damn word, which I'm really impressed with.
One of these days I'll have to swallow a tub of Pro Plus and stay up beyond midnight and see what happens on it. Anyway, thank you very much to you, Jack. Thanks very much to everybody else. Thanks for Tony for coming on next.
Yeah, thanks, Tony. You're a mate. Thanks.
Brilliant. And it gives me something to listen to with the kitchen posse after the show. Thanks again to Vin for doing the show before. I'm not likely to be around next week because I'm going to have what I suspect is going to be a pretty uncomfortable encounter with a dentist on Tuesday and probably won't be able to talk. So I'll be back with you a week on Thursday. In the meantime, this also was something I think somebody was chatting about last night. I've been listening to some of these Fatboy Slim mixes, and this is Jefferson Aeroplane versus Fatboy Slim doing Someone to Praise, followed by Dr. Doctor to play me out, and you're on 8 or 9 minutes, Tony, and you'll be there. Thanks, Jack. Thanks, everybody. See you all soon.